Okay, let's have a look at some of the modes of decay. So first of all, we'll start off with neutron-rich isotopes. Okay, sometimes they're referred to as radioisotopes because they're going to emit either particles of radiation or radioactive energy. Now, one of the examples of the unstable isotopes that I gave at you earlier was carbon-14. So if we have a look, we draw the symbol for carbon straight from the periodic table, the atomic number below, and then the mass number above. So 14 is the total mass of this particular isotope, and 6 is the atomic number. So therefore there are eight neutrons in carbon-14. So in order for neutron-rich isotopes to undergo decay in order to become more stable, what is going to happen is that one of these neutrons that's located within the nucleus of the atom, denoted by a small n, mass of 1, charge of 0, is going to undergo transformation to become one proton with a mass of 1 and a charge of +1, denoted by the P, okay, to say proton, plus an electron that has a mass of, that's essentially negligible, and a charge of -1. Okay, so what we're looking for with nuclear equations, as opposed to chemical equations, is for the total mass on both sides of the equation to equal, okay, so to be balanced. So one mass of a neutron, one mass of a proton, nothing for an electron, and no charge for the neutron overall, and then 1 and -1 gives us also no charge overall. Okay, so in a nucleus of a neutron-rich radioisotope, neutron undergoes this transformation to form a proton and an electron. Now, an electron has no place in the nucleus, so that's immediately expelled from the nucleus as soon as it's produced. The proton, however, is going to stay in the nucleus. So if we add an additional proton to the nucleus of carbon-14, it's going to increase its atomic number by 1. So that's going to increase to 7. Now, if we have a look at our periodic table, we'd have a look and work out that this has given us a new element of nitrogen. However, since we've lost one neutron and gained one proton, they both have a mass of 1, the overall mass remains 14. Okay, and what we write in our nuclear equation up here is that this has also produced an electron, which is emitted from the nucleus. Now, this electron is then referred to as beta decay. So that's one of the modes of decay, and I've written a little negative on there for a purpose. Okay, so we'll talk about that in a while, but this electron being emitted, we refer to it as beta decay.